Have you received the assignment for the chapter?
No, ma'am.
Are you guys checking your portal?
Yes.
But I think the office people have already uploaded that on the portal. Okay, just after the class, please contact Learnivio office for the assignment of chapter number 1. Okay. Get them on your WhatsApp if you're not able to access it on the portal. Today I'm going to start a new chapter, which is polynomials. Yes, Jaslene, are you here? Right now, first of all, let us try to understand what is a polynomial. So any expression I can take, for example, 2x cube plus 7x square minus of 4x plus 15. Let's say this is an expression I'm taking, algebraic expression. So here you can see the numbers which are attached to x, they are called as coefficients, right? Coefficients. And this x, this is known as variable, right? So this x is called variable. So expressions like this, which contain some variables and their coefficients, it's called a polynomial. Now, poly means many. So it can have many terms. It can have 1 term, 2 term, 3 term, 4 term. Now, what is a term? This, let's say 15 is one of the term of this polynomial. Understood? Term. So what are the terms? If I break, like 2x cube is one term of this polynomial. The second term is 7x squared. The third term is actually minus 4x. And the fourth term is 15. Understood?
Yes.
Okay. So the first term, if I look at the first term, which is 2x cube. So in this, you can see the coefficient is 2. And what is the variable? Variable is x. So the expressions like this, they are called as polynomials, which have different terms. Now, polynomial is classified according to two types. How? Classification of polynomials. First of all, they are classified according to number of terms. Number of terms, and second, according to degree of polynomial. So I'll explain what is a degree of variable. Or degree of polynomial also you can say, that's the same thing. Let's call it polynomial. Okay, now come to first classification according to number of terms. So if a polynomial has only one term, right? Only one term, it's called a monomial. Understood?
Yes.
If it has two terms in it,
Binomial.
it's called binomial. And similarly, three terms will be called as trinomial, and so on. So an example of monomial can be like simple 5, I can write the constant term, or I can take 2x, that's one example of a monomial. Then binomial will have two terms, so I can take like 2x plus 3, this is one binomial. Trinomial will have three terms, so it can be like 3x cube plus 3 minus 2x. This is a trinomial. Understood? Now, if I want to classify according to degree of polynomial, first of all, I have to understand what is the meaning of degree. Degree is highest power of the variable. Right? Highest power of the variable. For example, if I look at the same polynomial, 2x cubed plus 7x square minus of 4x plus of 15. So what is the highest power of variable you can see here?
7x.
No, power. Power is this. This is power. Right, Jaslene?
2x cube.
See, 2x cube is the complete term, but it is having, the x is having a power 3 in this case, isn't it?
Yes, ma'am.
So the highest power of x, like of the variable, is 3 in this term. The highest power of the variable is 2 in this term. Here, the highest power is 1. And sorry, the power is 1. And here, what is the power of x? 15
0.
is actually, yeah, it can be written as x to the power 0. When something is raised to the power 0, the answer is 1, right? 2 to the power 0 is 1, like that. So that
Yes.
means here the degree of x is 2 in this term, sorry, 0. So which term is having the highest degree? This is 3. So that this is a degree 3 polynomial. Understood?
Yes, ma'am.
So this is the meaning of degree. Degree is the highest power of the variable in the polynomial. Let me give you one more example. For example, I have this 2x square minus 6x5 plus 3x cube minus 1 plus 14x4. This is a polynomial, right? So what is the highest power of x you can see here?
5.
5. So this one is a degree 5 polynomial. Understood?
Yes, ma'am.
So this is the meaning of degree. I hope it is clear. This is important.
Yes, ma'am.
Now, according to the degree, how can we classify the polynomial? So the degree 1 polynomial is known as linear polynomial. Understood? Degree 1 is called linear. If the degree is 2, an example of linear polynomial means 2x plus 3. So the highest power of x is 1, right? Degree 2 will be known as quadratic polynomial. One example can be 4x square plus 3x plus 2, right? The highest power of variable is 2. And similarly, degree 3 will be called as cubic polynomial. So an example can be like 3x cube plus 2x square plus 5. It's not necessary that it contains all the power of x in descending order. Or simply we can have 4x cube. That's another degree 3 polynomial, right? Simple 4x cube, the highest power is 3. It's a degree 3 polynomial. Clear? Okay.
Yes, ma'am.
And similarly, you can name like degree 4. It's too much, but it's called bi-quadratic and so on. Just leave it. So up till here, you remember linear, quadratic, and cubic. Similarly, this can simply, if I write 5x square, that's it. This is also a quadratic polynomial, isn't it? It's not necessary that it should contain more than one term. Only one term can be there. So there is another term which is sometimes it's written constant polynomial. Now, what is a constant polynomial? Actually, degree 0, right? So basically, for example, if I simply write a number 15, that's it. So ultimately, 15 can be written as 15 into x to the power 0. So this is a degree 0 polynomial. So such numbers, like simple numbers, they're called as constant polynomial. Understood? Example, if I write simple 2, it's a constant polynomial, right? 6, it's a constant polynomial. Understood?
Yes,
13.
ma'am.
Okay. So I hope it is clear now. Now, one more thing you understand here. For a polynomial, let's say I give you two examples. One is 2x cubed plus 5x plus 3. Let's take different examples. So this is the first example. Second, I take under root 2x cubed plus 5 plus under root 3, right? X. Now, third example I take is this. I keep it 2, but I make it like, let's say 2x cubed plus 5 into under root of x, right? Now, variable is inside the square root and like this. Now, let us see whether they are polynomials or not. For a polynomial, for this expression to be a polynomial, the exponent of x, this is important, that the exponent of variable should be a whole number. Right? What is whole number? They start from 0 and then 1, 2, 3, and so on. These are whole numbers, right? So that means the x to the power, exponent means power, right? We have done in the previous chapter, exponent. So the x to the powers of x should be whole numbers only. They should not be negative. Even this fourth example, if I take, let's say I take 4x cubed plus 5 upon x, let me take, and plus 3. So in this, you can see the power of x are plus 3, plus 1, that is okay. In this also, second example, if I see, the power of x is 3 and 1, right? And 0, obviously here 0. So this is a polynomial. Similarly, this is also a polynomial because we can see that the power of variables are whole numbers. Is that okay? Now come to the third example. Here the power of x is 3. But here under root x, how we write? That means x to the power 1 by 2. This is how we write under root. Okay, please remember this thing if you don't know, that x to the power 1 by 2 is actually under root of x, right? Or if you have under root of x, you can write it x to the power 1 by 2. If you have cube root of x, this you can write x to the power 1 by 3, right? If you have fourth root of x, so this can be written as x to the power 1 by 4, so on. If you have like nth root of n, it will be x to the power 1 by n. Understood?
Yes.
So under root x means x to the power half. Now look at this half. This is not a whole number, isn't it? This is a rational number, but it's not a whole number. So this is not a polynomial. Is that clear?
Yes.
Okay, now come to the fourth example. So x to the power 3, that is fine. Now 5 upon x. So this is basically 5 into 1 upon x. So this can I write 5 into x to the power minus 1? X to the power minus 1 means 1 upon x. When you have negative power, so you take that in the denominator. So again, this minus 1 is not a whole number. It's a negative integer, but not a whole number. So this is again not a polynomial. So you can note these 4 examples, so that will give you a clear picture. Is that okay? Is that clear?
Yes.
Which
Yes,
expression
ma'am.
is a polynomial and which is not? Now, one more thing you understand here. It's not necessary that the variable is always x, right? So if I take an expression, for example, 2x cubed plus 6x plus 3. So this is a polynomial in variable x, right? If I simply convert it like 2t cubed plus 6t plus 3, so it becomes a polynomial in variable t, understood? So you can take any variable. Now, because this has only one kind of variable, so I mean, only one variable is there in this polynomial, but you can have this way also. So this is a polynomial in two variable, understood? This is called polynomial in two variable. This is a polynomial because the powers of variable are whole numbers. So this is a polynomial, but it is having two variable. This we call polynomial in one variable. Understood? This is again a polynomial in one variable. Is that okay?
Yes.
Yes, ma'am.
Okay. So I think let us come straight to the exercise. Yeah, please open your book. Just open mine. Right, exercise 2.1 now. First question. Which of the following expressions are polynomials in one variable, right? And which are not? So the first part is this 4x square minus of 3x plus 7. So how many variables are there? One variable, right? Only x is there. And you can see the power of x are whole numbers. Clear?
Yes.
So we write that this is a polynomial in one variable. Second part, y square plus under root 2. How many variables are there?
1,
One. And what is the power of the variable?
2.
2. Now, one important thing. I just forgot here. For example, again, I'm coming back to this 2x cube, right? Plus under root 3x square minus of 6x plus under root 2. This is a polynomial. Now, the condition I told you was about the variable. The variable should have a power of whole number. But the coefficients, right? All these coefficients, they are real numbers. Understood? Real numbers means they can be rational also. They can be irrational also.
Yes.
So rational means they can be p by q form also. We can have 2 by 3 kind of coefficient also, right? For example, if I can have a term like 4 by 3x to the power 4, if I add something, so this is acceptable, this is okay, right? So this type of coefficients can also be there. This is simple positive integer. Now this is an irrational number. So this kind of coefficient can also be there, right? This is
Yes.
simple and negative integer. This is again an irrational number. This is a constant polynomial. So they have to be real numbers, and real, you know, they include rational as well as irrational. So you can have decimal coefficient, you can have fractional coefficient, you can have under root kind of coefficients. That is okay. but only the variable should have powers of whole number. Is that understood?
Yes.
Okay. So now you come to this. So here the variable is having power 2. This is okay. This is the constant polynomial. So this is a polynomial in one variable.
One variable.
Yeah. I hope it's clear to everyone. Okay, third. So 3 under root t plus t under root 2. First of all, is it a polynomial?
No.
Jaslene, I can't hear you. Please unmute yourself, Jaslene. Zeba. Yes,
ma'am.
Jaslene. Yeah. Is this a polynomial, Jaslene?
No.
Why no? Give reason. Okay, Zeba, why it is not a polynomial? Give me reason. Okay, it is not a polynomial. But why? Tell me. Zeba, I can't hear you. Say something, at least hi.
Hi. Yes, ma'am.
Yes. Okay. Why it is not a polynomial, Zeba?
Because it has a root.
Which number? 2 is also having a root. T is also having.
T.
Yeah, because the variable is not having a power of whole number, right?
Yes.
Right, Jaslyn?
Yes, ma'am.
Yeah. So here t is the variable. This is t root 2, right? So t
Yes, ma'am.
here power is 1, that is okay. But here t is under square root. That means t is having a power of half, which is not a whole number. So here we write variable. How will you write it? The power of variable is not a whole number. Understood? Whole
Yes.
number means it should start from 0 and 1, 2, 3. So therefore, not a polynomial. Next. Fourth part. This is y plus 2 upon y. Now, Zeba, is this a polynomial?
Yes, ma'am.
Why? Jaslyn, is it a polynomial?
No, ma'am.
Why no?
Because there shouldn't be no fractional numbers for binomial.
The coefficients can be fraction. Okay, you are right, but you're not able to put it into words. Zainab, why is it not a polynomial?
Because it has fraction.
Okay, I think you understand, but you're not able to say it properly. It can have a fraction like this. Then
It's
also I can say
irrational.
not irrational. Basically, you can write it like this. This can be written as y plus 2 into, now 1 upon y can be written as y to the power minus 1, isn't it? Yes. So 1 upon y is not irrational, right? First of all, it's a fraction, but the power is not a whole number. So define everything in terms of whole number. Remember this word, right? So it is a whole number or it is not a whole number. That's it. That's all you have to see. So here the power of variable is not a whole number, not a polynomial. right?
Yes, ma'am.
Power of variable is not a whole number. Fifth, now we have x to the power 10 plus y to the power 3 plus t to the power 50. Is it a polynomial? Okay, Jaslyn, what do you think? It is a polynomial? Is it a polynomial?
Yes, ma'am.
Yes, it is a polynomial because the powers are all whole numbers, but the variable is not one, it is 3. So it is a polynomial in 3 variables. Understood? Right. Now question number 2. Write the coefficients of x square in each of the following. So first is this 2 plus x square plus x. So what is the coefficient of x square here?
2 or 1.
1. Yeah, with x square nothing is multiplied, that means 1. Second, you have 2 minus of x square plus of x cube. Yeah, what is the coefficient of x square?
-1.
Minus 1. Good. So don't forget this minus. Okay. Third, and now you have pi by 2 x square plus x. Is it a polynomial? First of all, tell me. Jaslyn, is it a polynomial?
No.
Okay. Zeba, what do you think? Is it a polynomial?
No. It's not a
Okay.
polynomial.
Zainab, is it a polynomial?
No.
Oh God, all 3 of you are wrong. Now, I explained you. What I explained you, you only have to look at the power of the variable. That's it, right? Go back to the slides. What I told you, these numbers, they are actually real numbers. They can be rational, they can be irrational also, isn't it? This pi by 2 is not a variable. This is the coefficient of x square. The coefficient can be irrational. There is no problem, right? As in this case, the coefficient was an irrational number, isn't it? But this was a polynomial of degree 4, isn't it? So try to understand this thing. Okay, whether it is a polynomial or it is not a polynomial, you will only look at the variable. That's it. Okay? Only look at the variable, not the coefficient. Now, what is the variable here? Variable is this, x square. That is okay. Power is 2. It's a whole number. Here the power is 1. That's a whole number. So it is a polynomial, first of all. Is this clear to everyone?
Yes.
Okay.
Yes.
So please don't do this mistake again. You only have to look at the variable. That's it. Okay. So it's a polynomial, first of all. Now, what is the coefficient of x square?
Pi by 2.
Pi by 2. So this pi by 2 is a coefficient. It's a number. It can be irrational. There is no issue. Fourth, under root 2x minus 1. Now, is it a polynomial?
Yes.
Yes, it is, because the power of variable is 1. That's it. So what is the coefficient of x square?
Root 2.
Root 2 is a coefficient of x only, right? It is only x. That means x to the power 1. And you have to write the coefficient of x square. See here, it is only root 2x minus 1. So you can add x square with the coefficient 0. Does it matter? 0 into x square is 0. So if you don't have this term, that means the coefficient of x square is 0 in this expression, right? That is why it has gone. It is not written. Is that clear?
Yes, ma'am.
Yes.
Okay, next question number 3. Give one example each of a binomial of degree 35. So you have to write a binomial of degree 35, right? So you have to take two terms binomial. It should be a binomial. It should have a degree 35. Binomial means how many terms?
2.
2 terms.
Two terms. So write any polynomial, let's say 3y, okay, 3y and plus something, let's say 6. So two terms are there, but the degree have to be 35. So you have to put the degree 35. Is that clear?
Yes, ma'am.
Yes.
So this is a binomial because of two terms and it is having a degree 35. Another example you can write like this also, 35 and plus 2 into y to the power 30, no issue. Because for degree we look at the highest power only, right? You can have other powers, no problem. But it is defined by the highest power. Is that clear? So this is also a binomial of degree 35. Okay, and of a monomial of degree 100. So you have to write a monomial of degree 100. How many terms are there in a monomial?
1.
1. So you have to take something like 6 t, only one term, but degree 100. So
30. 100.
yeah, t to the power 100. So it is having a degree 100, but term only 1. So it's a monomial of degree 100. Okay, just look at question number. Oh yeah, sorry. Now next question number 4. Write the degree of each of the following polynomial. So I think you will be able to tell me now. So 5x cubed plus 4x square plus 7x. Okay, Jaslyn, what is the degree?
3.
3, yes. Next, you have 4 minus y square. Zeba, what is the degree here?
2.
2, good. Then next you have 5t minus under root 7. Yes, Zainab, what is the degree?
1.
Okay, degree is 1. And then 3, what is the degree?
0.
0.
Degree 0, right? Okay. Next question. Classify the following as linear, quadratic, and cubic. So this also I told you. X square plus x. So depending upon the degree, we classify it as linear, quadratic, or cubic. So what is the degree here?
Quadratic.
Yes, so it is the degree 2, that means quadratic. Now x minus x cube, Jesslyn, what is the degree?
Cubic.
Yeah, it's a cubic because it's at degree 3. Then y plus y square plus 4. Seba, what is the degree here?
Quadratic.
Quadratic. Right. Then you have 1 plus x. Yes, what is it?
Linear.
Linear. Only 1 degree.
Then 3t. What about this? Degree 1, right? T is the variable this time. So it is having a degree 1, which is linear. R square. What is it?
Quadratic.
Quadratic. And 7x cube.
Cubic.
Cubic. Right. So according to the degree, these are the names. And if I want to add the name according to the number of terms, so this is having a 2 terms. So this is binomial, right? So this is quadratic and binomial. Understood? Similarly, this is cubic and binomial. I mean, it's not asked, but I'm just telling you. So this is quadratic, but it is a trinomial. Is that okay? This is linear, but it is binomial because it is having 2 terms. Similarly, this is linear, but it is a monomial because it is having only 1 term. Again, this is quadratic, but a monomial. And similarly, this is cubic, but a monomial. So both way you can name according to the number of terms, according to the degree. Okay. Now let us come to some important topic next. First of all, let us know what is called value of a polynomial. Right? Value of a polynomial. Like how do we find a value of a polynomial? For example, I have a polynomial which we call like this. If I'm having a polynomial in x, for example, 8x squared minus 3x plus 7. So I can give it any name. I can call it p in variable x. This way I can name it, right? Or I can call it f, any name you can give and put a bracket. So it is a polynomial in x. So I write like this. If it is if it is like this, 8y squared minus 3y plus 7. So I write py. Understood? This is a polynomial in y. Is that okay? So this is how we name it. Now, what about the value of a polynomial? So I can take up different values of y. Y is what? Y is variable. Variable means this can take up any value. The value is not fixed. It can take up different values. So I can give different values to y. Let me take y is equal to 1. So I write p1, right? At y is equal to 1, I'm finding out. So you put 8, then 1 square minus 3 into 1 and plus 7. So what do I get? 8 into 1 square is 1 minus 3 plus 7. So that means 8 minus 3 plus 7. So that means how much? 8 plus
Nice.
4, that is 12, right? Okay. So at y is equal to 1, the value of my polynomial is 12. So this 12 is called the value of polynomial at y is equal to 1. Understood? Right? Similarly, I can take up different value of x. Let me take y is equal to 2. So let me try to find out y is equal to 2. So what does it become? 8 into 2 square minus 3 into 2 plus 7. So that becomes 8 into 2 into 2, 4 minus 3 into 2, 6 plus 7. Okay, 4 into 8 is 32 minus of 6 and plus of 7. So that means 32 plus 1, that is 33. So polynomial at y is equal to 2 is equal to 33. So this 33 is the value of polynomial, value of py you can say at y is equal to 2. Understood? How do we find the value of a polynomial? So the value is found at some given value of the variable. Is that okay?
Yes.
Okay. Let me take just one more. I want to explain something. Let me take a polynomial fx, which is x cube minus 6x square plus 11x minus of 6, right? Okay, let us try to find x is equal to 1. So what does it become? 1 cube minus 6 into 1 square plus 11 into 1 minus 6. So that becomes 1 minus 6 into 1 is 6 plus 11 minus 6. That becomes 12 minus 12, right? That becomes 0. Have I done it correct? All the calculation? 1 plus 11 is 12. Yeah, right. So I'm getting 0, right? Now, in this case, when my value of the polynomial is coming out to be 0, so that means this particular value which I have chosen for the variable, this is called the root of this variable, of this polynomial. Root or 0, different names we can give. Understood? So I can say that x is equal to 1 is 0 of this polynomial, 0 or root of this polynomial. Is this understood by everyone, Jaslyn?
Yes, ma'am.
Okay. Because x can take up different values. It can be 1, 2, 3 or some negative value. So if at any particular value, the value of the polynomial becomes 0. So that value which you have chosen for the variable, that means that is one of the root of this polynomial. That is why you are getting a 0. Is that clear, Zeba?
Yes, ma'am.
Okay. So let us come to exercise 2.1 now quickly. Right. Exercise 2.2, sorry. First question. Find the value of the polynomial. So some polynomial in x is given, which is 5x minus 4x square plus 3, right? So you have to find first at x is equal to 0. So let us do it. So p at 0 is equal to 5 into 0 minus 4 into 0 square plus 3. So that becomes 5 into 0 is 0 minus again 4 into 0 will become 0. So 0 minus 0 plus 3. So only 3. So at x is equal to 0, the value of the polynomial is 3. Second, at x is equal to minus 1. So p at minus 1. What does it become? 5 into minus 1 minus 4 into minus 1 whole square plus 3. So you get minus of 5 minus 4. Now minus 1 into minus 1. You will get plus 1, right? Minus minus will become plus 3. So minus of 5, then minus of 4 plus 3. So you get minus of 9 plus 3, which is equal to minus of, 3, which is equal to minus of 6. So that's the value of the polynomial at x is equal to minus 1. Let us do the third one also at x is equal to 2. Find p at x is equal to 2. So 5 into 2, right? Minus 4 into 2 square plus 3, right? So 5 into 2 is 10 minus 4 into 2 into 2, that is again 4. So 10 minus 16 plus 3. So this is equal to 10 plus 3 is 13 minus 16. So that becomes minus of 3. So that is the value of the polynomial at x is equal to 2. So I hope everyone has written it.
Yes, ma'am.
Okay. Next question. Question number 2. Find P0, P1, P2 for each of the following polynomials. So I'm not doing all of them. Let me take fourth part, right? So P of x is equal to x minus 1 into x plus 1. So you have to find P0, P1 and P2, right? So let us first find P0. So wherever you have x, put 0. So it is 0 minus 1 into 0 plus 1. So that becomes minus 1 into obviously plus 1. So that becomes minus of 1. Clear? Now find P at 1. So wherever you have x, put 1. So 1 minus 1 and then you have 1 plus 1. 1 minus 1 is 0 into 2, that becomes 0. So can I say x is equal to 1 is one of the root of the polynomial or 0 of the polynomial? Yes? Because I'm getting 0, so that means x is equal to 1 is the 0 of the polynomial. Let us find P2. So put 2 minus 1, 2 plus 1 in place of x. This is 1 into 3. This is 3. So rest of the 3 parts you can do same way. Shall I leave it?
Yes, ma'am.
Okay. Third question. Verify whether the following are zeros of the polynomial indicated against them. The first, px is 3x plus 1, right? And some value of x is given, that minus 1 of 1 by 3. So you have to verify whether x is equal to minus 1 by 3 is a 0 or not. So for it, what will you do? You will check the value of the polynomial. If it is coming out to be 0, then it is 0 of the polynomial. Understood? This term 0 is actually very confusing. We don't understand whether I'm calling 0 or I'm calling 0, right? So you can call it root also. There's no issue. Is that okay? 0 or root means the same thing. So let us check P at x is equal to minus 1 by 3. So that means wherever you have x, you put minus 1 by 3. So 3 into minus 1 by 3 and plus 1. So 3 cancels out. You have minus 1 plus 1, that becomes 0. So your value of the polynomial is coming out to be 0, right? Therefore, x is equal to minus 1 by 3 is 0 of this polynomial. Let me do the seventh part. Please let me know if you have not written. I'll just scroll back. Px is 3x square minus 1. And then you have to check at x is equal to minus 1 upon under root 3 and 2 upon under root 3. So one by one we will see. So P at x is equal to minus 1 by under root 3. That means 3 into, now put minus 1 by under root 3 whole square and minus 1, right? That becomes 3 into, so minus 1 by under root 3 means minus 1 by under root 3 into minus 1 by under root 3. So minus minus will become plus, right? So in the numerator you get only 1 and under root 3 into under root 3 is 3. Is that okay? So 3 cancels out. So it's only 1 minus 1, that is 0. So that means x is equal to minus 1 by under root 3 is 0 or root of this polynomial of Px. Now let us check P2 by under root 3. That becomes 3 into 2 by under root 3 whole square minus 1. That is 3 into, so 2 square is 4, root 3 square is 3 minus 1. So 3 cancels out, so only 4 minus 1, which is 3, right? It is not equals to 0. So we write that x is equal to 2 by under root 3 is not a 0 of Px. So can I leave the other parts for you in the homework?
Yes, ma'am.
Okay. Last question also, let us see. So this exercise will be over. Fourth one. Find the 0 of the polynomial in each of the following cases. For example, first you have Px is equal to x plus 5. Now try to understand. Nothing is given, right? Only polynomial is given. You have to find its 0. Now come back to the definition of 0. What is a 0? 0 is that value of x, right, at which your Px becomes 0. Is that okay?
Yes, ma'am.
So for 0 or root, I call it root sometimes, set Px is equal to 0. I mean, if you are setting your polynomial equal to 0, so whatever value of x you will get, that value will be the 0, because already you have set your polynomial equal to 0. Understood?
Yes, ma'am.
I mean, go in the reverse order. You have already set your polynomial is equal to 0. Now whatever value of x you obtain from this, like after solving this, so that is going to be one of the root, because at the root only this happens, isn't it? Right?
Yes, ma'am.
Okay, so we are doing the reverse thing. So you write this sentence that for 0, set x is equal to 0. So we set x plus 5 equal to 0. So from here we get x is equal to minus 5. So x is equal to minus 5 is the 0 of Px. Is this understood by everyone?
Ma'am, how is
Yes.
it minus 5?
Yeah, because x plus 5 is 0. Now take 5 on the other side.
Okay.
Yeah, so basically it will be x is equal to 0 minus 5, which is actually equal to x is equal to minus 5, right?
Yes.
Okay, one more part I can take. Let me take second. No. Second is same, like third, fourth are same. Let me take fifth part, right? Fifth part, Px is 3x. So again, 4, 0, set Px is equal to 0, right? So 3x is equal to 0. That means x is equal to 0 by 3. That means x is equal to 0, right? So x is equal to 0. is the 0 of Px. So please don't get confused between this 0 and this 0, right? This term is a bit confusing, but I hope you understand it now. What does it mean? Okay, let me take, similarly the next, right? You have Px is equal to Ax, right? And it is written that A is not equal to 0. Because they have to write, otherwise if A is 0, your polynomial Px is equal to 0, right? So polynomial is something where A is not equal to 0. A can be anything else. Now for 0, set Px is equal to 0. So we write Ax is equal to 0. So x is equal to 0 divided by A. So that gives you x is equal to 0. So x is equal to 0 is the 0 of Px. Is that okay? Whatever value of x you are getting now will be a 0 because you have already set your polynomial equal to 0. Right? One last part. It is written that Px is equal to Cx plus D, where C and D are real numbers that we know coefficients are always real. C is not equal to 0 because C is 0, so x term will be gone, right? So there will be no x term. That is why they have to write that C is not equal to 0. Anyway, now for 0, set Px is equal to 0. So you set Cx plus D is equal to 0. So Cx is equal to D will go other side, it will be minus D. And C will come in the denominator, it will be minus D by C. So x is equal to minus D by C is the 0 of Px. Is there any exercise which is deleted from this chapter? In your school, is it told?
No, ma'am.
Okay. Anyway, in the last class, we will be doing remainder theorem and factor theorem. So I hope. Any question? Any confusion so far? Jaslene, any questions so far?
No, ma'am.
So I hope it is clear to everyone. Like today in this class, we have understood what is the meaning of 0, right? This is something important. In the 10th class also, you will be using it. Again, you will be having chapter polynomials in 10th class. Okay, then I'm ending the class today. We will be meeting in the next class on Saturday. Okay.
Thank you, ma'am.
Oh, okay. Bye.
Thank you, ma'am.